things happening here. I usually find kids have forgotten how to multiply fractions. And I'm gonna also show you a trick that's gonna be helpful to us. Multiplying fractions, in my opinion, is like the easiest thing you can do with fractions. It's easier than adding and subtracting. Because do you have to have common denominators to multiply fractions? You do not. You have to have them to add or subtract. That's why we're multiplying and dividing before we add or subtract, because it's a little bit easier. Who can tell me what I need to do to multiply fractions? Straight across. Not cross multiply. Some of you were doing like 3 times 7 is 21, and 4 times 12 is 48. What you're thinking of, you're not crazy, but you're thinking of like when you had like 3, maybe like 3x over 7 equals 12 over 5 or something like that, and you cross multiplied to solve that equation. So that is when you would cross multiply. It is not what you do for fractions. You just multiply straight across. So you have a couple options. You can just multiply straight across. You'll get 36 on the top. You'll get 28 on the bottom. And then it needs to be reduced. So how do we reduce that? We're going to divide. What will go into both of those? 4. So if I divide by 4, I'll get 9 in the top. If I divide by 4 in the bottom, I will get 7. So 9 sevenths. Okay. Here's another option and something that I want us to try to do because it's definitely sort of what we're doing today. You can reduce before you multiply. It makes it a little bit easier. You don't have like such big numbers to reduce at the end. So we got 3/4 times 12 over 7. 3/4 will not reduce. 12 over 7 will not reduce. But 4 and 12 can reduce. You can reduce anything on the top with anything on the bottom. So if I reduce that, I could divide both of those by 4. This would be a 3, and this would be a 1 if I reduce that. And then I multiply straight across, and it gets me straight to 9 over 7. So that is a trick that we want to kind of employ here whenever we're dealing with this. So on this next one, it's especially helpful because 24 times 5 is a big number, and 15 times 8 is a big number. Those are numbers bigger than you learned for your multiplication tables, right? But I can reduce before I multiply. So anything on the top can be reduced with anything on the bottom. There's a couple different ways you could do this, but I see a 5 here and a 15 here. So this is a 1, and this is a 3 right here. All right, if I divide both of those by 5. And then I've got an 8 and a 24. What number would go into both of those? 4 would work, but 8 would be even better. That's the biggest number. So if I divide this by 8, I'll get 3 right here, and I'll get 1 right here. And you could go ahead and multiply. You could reduce again with those 3's, but you're going to get 3 over 3. And what is 3 over 3? 1. For that. So to multiply fractions, you multiply the numerators together and then multiply the denominators. Together. You can reduce before or after you do that. In my opinion, it is the easiest thing that you can do with fractions because common denominators are kind of a pain whenever you have to do that, but you do not need them here. Now, we are reviewing this because we're about to throw some x's in here and the same rules of fractions still apply. So, we still need to talk about restricted values. So this is just sort of a refresher from yesterday. Any value that makes the denominator of a fraction equal to 0 is a restricted value. So, this is very similar to what we were doing yesterday. Our problems are getting bigger here, right? Because we are multiplying these two things together, right? Now, just like yesterday, I want to factor everything, except if I look at this first problem, I think that t squared plus 19t plus 84 will probably factor. But, like right now as it is, this stuff is all multiplied, right? So I've got t squared plus 19 plus 84t right here on the top. And I've got t squared plus 9t plus 14 on the bottom. What's going to happen with those two? Like, they're going to factor to be the same thing, right? If they do factor. I could go ahead and mark these out because they match for that. So if you already see something that's the same on top and bottom that's an entire factor, like the whole thing, you can mark those out. It will make it easier because you don't have to worry about factoring that. Now, if you look over here on 4, that's not going to be the case. You don't have anything that matches exactly. You don't have to factor everything here. But that leaves us with just the 2t minus 2 over 4t minus 4. And so for that, there's not much factoring you can do there, but you can do a GCF. So I could pull out a 2 out of that numerator, so it'll be t minus 1. And then in the denominator, I would have 4 and another t minus 1. Oh, you know what because of, oh wait, hold on. Did I look at that wrong? That's not 84, is it? Was it 84? Oh, I'm sorry. We're going to have to back up. Sorry, guys. We're going to need to factor like this. In fact, actually, since I've already got us started on this, I looked at that wrong. Just make it an 84. This might happen sometimes. We're going to make that an 84. I don't like backtracking all the way when that's a little ways to go there. So, for this, these cancel. We've got 2/4, but 2/4 will reduce. We will just get 1/2 for that. Now, we are still actually going to have to factor that t squared plus 9t plus 84 because we need to know excluded values. And excluded values, we have to know what it is even before we cancel. So right here for the 4 and the t minus 1, nothing can make 4 0. There's not an excluded value for that. T minus 1 is going to give us t equals positive 1 for that. And then for this, to know what makes that 0, I am going to need to factor that. So if I factor this, you know, I am going to multiply to get 84. I'm going to add together to get 9. 84 is going to be I'm going to have to pull out the Desmos on that one. Maybe it's 6. Let's see if we can find that one. Actually, I've messed the whole problem up. I can't change it to an 84 because then it doesn't, because that was a 19. I'm really looking at it wrong. Well, let's make it wrong. We'll abandon this problem. This problem has been abandoned. I've messed it up. So, ignore excluded values. I made something that won't factor here. So, that's the issue. So, I apologize for my mistakes there. All right, let's go to 4. Let's try not to mess this one up, okay? I've messed it up beyond repair. We could go back and redo it. I just don't want to since we've already done that. All right, 4. We're going to factor everything. Y'all should have stopped me earlier. Y'all should have, all right, Miss Hyatt, you're crazy. I seemed too confident, didn't I? Yeah. Yeah, I think so. I think that killed a math fairy right there. Right here, we need to just go ahead and factor everything. Okay? So everything will factor except for the x minus 5 because it is just x minus 5. So for this first one, we're trying to multiply to get negative 6. We're trying to add to get a positive 1. What numbers could I use for that? Two and 3, what signs do I need on it? Negative 2, positive 3. Will that work? Yep. So that's going to be x minus 2, x plus 3. Here. And then I've got x squared minus 25. So that one, I've got negative 25. And what's my middle number on that one? It's 0, right? So what numbers have to work? Like, what's the only thing that's going to work here? Positive 5, negative 5, because that's the only one we'll get zeros. Have positive and negative of the same number. So I'll have x plus 5, x minus 5. And then my last one here, I've got a positive 3 that I need to multiply to get. I've got a 4 that I need to add to get. What numbers could I use there? 3 and 1. So positive 3, positive 1. So x plus 3, x plus 1. Okay. Now, since I've done this one correctly, we can do excluded values, but we need to do excluded values before we start marking things out, or restricted. It does say restricted here instead. So it's anything that would make the denominator of any of the fractions 0. So we're just looking at these 3 pieces right here on the bottom, only the bottom. So x minus 5 would give us x equals positive 5. Right? That's an excluded value. For x plus 3, I'd get negative 3. And for x plus 1, negative 1. So now I can cancel anything on the bottom with anything on the top, because whenever I multiply fractions, I just multiply straight across. So what's really happening here is it's like you really just have one big fraction, right? All that stuff is multiplied on the top. All the stuff is multiplied together on the bottom. I can just start canceling. So I can see that I've got an x plus 3 right here and an x plus 3 on the bottom. I've got an x minus 5 and an x minus 5 right here. And so whenever I do that, I've got x minus 2 times x plus 5 over x plus 1. And that would be my simplified answer. Now, we're not going to do this on every one, but whenever you get these problems, a lot of times they will be, there we go. A lot of times they will be multiple choice problems on a test for this. So if you're stuck, if you're having trouble, you can type these in. They're long, so it takes a while, and you have to be careful not to type them in incorrectly. But if I type in the original, like this, looks like this, you'll get some crazy graphs on some of these. And then I type in this. Oh gosh, what have I done? I've done something wrong. Make that bigger so you guys can see. Somebody help me find my mistake. I'm falling apart today. It was a -2, okay. Whew. All right. Okay, now they match. So that lets you be reasonably assured that you got it right. Now, if you have something you didn't cancel, like say I had an x minus 5 on top and bottom that I left there, it would still look like it's correct, but it usually will help you see if you've made a mistake right there. Okay, questions? All right. Dividing fractions. So my saying that I say a lot of times, there's other sayings. You may have had teachers that use different little things to help you remember how to divide fractions. What I say over and over and over again, I find myself saying this, like even in calculus, is dividing fractions, easy as pie. Flip the second and multiply. You guys may have had different ones that you have learned. You might have another one they remember a teacher saying a lot. This is my favorite one. It's a cute little rhyme. So whenever we're dividing fractions, so these are just numbers this time, right? We're just practicing with numbers before we throw some x's in there. When we divide fractions, we flip the second fraction and change it to multiplication. So what that looks like for number 5 is that we got 5 over 6 times we flip the second fraction, 18 over 25. Like that. I personally would reduce before I multiply here. Okay, so if I reduce before I multiply, 5 right here is a 1, the 25 is a 5. 18 and 6 are both divisible by 6, so 18 divided by 6 is 3. 6 divided by 6 is 1. If you do this ahead of time, then you don't have to reduce your fraction at the end. And most of the time it's easier to reduce when you got small numbers. So you'll have 3/5 because you'll be multiplying 1 times 3, which is 3, 1 times 5, which is 5. Sometimes kids get thrown for a loop when they see one that looks like number 6. We call that a complex fraction. It's when you got fractions inside of fractions, right? It's like the nightmare of fractions for those of you that hate fractions already. But what it really is it's just 7/8 divided by 14/3. Which one of those, which fraction is the second? The bottom, right? So you are going to do 7/8 stays the same. You change it to multiplication, and then you flip 14 over 3. So that's going to be 3 over 14. To me, it's a lot easier if you go ahead and simplify right now. Does anybody see anything that'll simplify? 7 and 14 are both divisible by 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. Then just multiply straight across. 1 times 3 is 3. 8 times 2 is going to give us 16. That won't reduce any further, so that's our answer. Dividing fractions is really only just a little bit harder than multiplying the fractions because you just have that extra step where you've got to flip there. It's only for division. What I find is sometimes when we start doing division problems, kids start flipping multiplication problems. If you got a multiplication sign, don't flip anything. There's no flipping for that. It's only for division. All right. So let's do a couple of these, and then we are going to be on our way so that you guys can practice some on your own. For problems like number 7, it is up to you whether you want to factor first or factor after you flip it. It doesn't matter, really, whether you factor first or factor after you flip it. If you are very careful, you could do both at the same time, but be careful if you do that. I think I will go ahead and flip it first, and then we'll factor. So that first fraction right there, a plus 2 over a plus 3, will stay the same. We'll switch this to multiplication, and we'll have a squared minus 9 over a squared plus a minus 12. And so now we would want to factor. A plus 2 and a plus 3 do not factor. They just stay like they are. You might want to put them in some parentheses just to remember all of that is multiplied together. Okay, and then we want to factor top and bottom of number of the second fraction. So looking at that, I've got a squared minus 9. How does that one factor? Not 9 and 9. I need to multiply to get negative 9. I need to add to get 0. The middle term's missing. Positive 3 and negative 3. It's a difference of squares. So I'll have a plus 3 and a minus 3. On the bottom, I'm multiplying to get negative 12. I need to add to get a positive 1. What numbers would work for that? Negative 3, positive 4. Negative 3 times 4 is negative 12. Negative 3 plus 4 is positive 1. So that would be a minus 3, a plus 4. Now, excluded values are, in my opinion, a little annoying for this. For your excluded or your restricted values, you cannot have 0 in a denominator at any time. So, that means the denominators here were a plus 3 and a squared minus 9, right? But once we flip the fraction, there's my a plus 3. Now my a squared minus 9 is in the top, and this is in the bottom here. So, we can't have zeros in any of those places, right? So, really, top or bottom of the second fraction cannot equal 0. And then the bottom of the first fraction cannot equal 0. So, we're looking at all three of these right here. We don't do that for anything else except for division, because we can't have 0 in the denominator at any point. So we will get a equals negative 3. Right here, that would be another a equals negative 3, so we don't have to list it twice. Here we would get a equals positive 3. Here, another a equals positive 3. You don't have to list it twice. And then we get a equals negative 4. Now we can start marking things out. A plus 3 cancels with a plus 3. A minus 3 cancels with a minus 3. And we will get a plus 2 on the top and a plus 4 on the bottom. Okay, questions so far? All right, for number 8, these look terrible. They look sort of terrifying. But I like to kind of put some parentheses around the top, parentheses around the bottom. This is just a fraction divided by a fraction. Rewrite it as multiplication. So we would have b squared over 25a squared minus b squared times, you got to flip the bottom fraction. The bottom fraction is your second fraction, so you got 5a minus b over b. For this, there's really only one piece of this that is going to factor. It's only that 25a squared minus b squared. This one's also made a little bit more difficult by the fact that it's got two variables in it. whenever you are factoring and you've got two variables like this, it can still be done with X method, but your first term here will have an A with it. Oh, I don't need to write that there. We'll have B squared over. Your first term will have an A, your second term will have a B. And then on this you'll have first term will have an A, second term will have a B. So you'll have that pattern show up, where normally we just have the number for the second part. So if we factor this with the X method, then I've got 25, and then that B squared has a negative 1. So 25 times negative 1 is negative 25. And then what number is my middle number here? It's 0, because I'm missing the middle term. So that means I'd have to get positive 5, negative 5. But this one had a number in front of my A squared. What have I got to do after I find my two numbers? I got to divide by that 25. Okay, so I'm going to divide both of these by 25 right here. And what does 5 over 25 reduce to? It's almost 5, but 5's on the bottom, right? It's going to be 1/5. And then over here, you'll get negative 1/5. The X goes with what's in the bottom. So well, in this case, it's not an X, it's an A. So we're going to have 5A plus 1B and 5A minus 1B there. And the 1s are unnecessary. So whenever I'm looking at this, that 5A minus 1B and the 5A minus B, those can cancel. There's one more thing that can cancel. I can cancel one of these B's, because that B squared is really like having two B's right there, right? It's like B times B. So I can take this B right here. And I can cancel it with one of those B's up there in the top. So I will get B over 5A plus B. And I realize that my work is a little all around the world there. I ran out of room. Now, I did kind of ignore excluded values on this one so far. Excluded values are weird for this. You would have to look at this section, and this section. You are definitely, for your excluded values, going to get that B cannot equal, or B equals 0. The other ones are different because you got 5A plus B, and that can't be 0. I really don't want to spend like too much time with this. We got 5A plus B. It cannot equal 0. So if I move the B over, like 5A equals B. So basically, B cannot be 5 times A. If it is, you end up with a 0. And you'll have the same thing, 5A minus B. I'm sorry, that'd be a negative right there. Equals 0. So this one actually is going to be your 5A equals B. You also got like negative B cannot equal 5 times A, or you could do B equals negative 5A. I'm not overly concerned with whether or not you've got that right. If I ask you for excluded values, I'm probably going to do more like number 7. Probably not one with two variables, because it's not really a focus that we're looking at. Okay, questions? Let me see if I've got anything on this last one that we just really have to see. I don't really think so. How do you factor 7x to the third plus 49x squared? I think I'm hearing whispers. What? Not on this one. It's a GCF. When you do have a number in front of your x squared, sometimes you have to do that. But in this case, because you're missing those like last terms, everything has an x, you would do divide by 7x squared, like factor out a 7x squared. So you'd have like 4x squared over 7x squared times, this is just going to be x plus 7 here. Let's just go ahead and finish this one out. We're too close. Right? So then that 7x squared can cancel with that 7x squared. The 4 can cancel with the 4. This x can cancel with one of the x's up here. And we would end up with x over x plus 7. So don't forget about that GCF factoring. Sometimes you need that instead of doing X method for that. If everything has a variable with it, that's when you're going to do GCF for sure. Sometimes if it's just numbers, but definitely if it has variables with every term. Okay, I want you guys to have some time to work on your assignment.